Okay. Calc 2, lecture 20, Calc 4, lecture 28. That is differential equations again, first order DEs and linear differential equations. In fact, this linear differential equation comes first in Calc 4, but in Calc 2, it is like after the separable equation. So anyway, that doesn't make much difference. So, linear differential equation is something like that. So I assume that y is a function of t. Now, it can be a function of x. But anyway, if y is a function of t time, then I have derivative. Then here I have pt, a function of time times y, and on the other side I have a function of time, qt. This I call standard form. You can write it as y prime, this first one, so it can be, you might see it like this, not like that. Anyway, they're the same. So this is called standard form. You have to put this in standard form to solve it. I mean, it's better to do it, okay? So let's solve it. Let's look at this. This has y prime, and here if I have y. Where have you seen something like this? Some kind of expression. Let's go back to Calc 1, f g prime. So that is f g prime plus f prime g. So this looks like I have g here and g prime here, and I have g here, right? This is like y prime y, y prime y, right? And this it's not the derivative of something. I haven't written p prime, but you can find its antiderivative. Well, what is this f here? So I can ask this question. I can say, or put it this way, say, let's ask this question. Can I find a function? Can we find a function mu t? Before I say that, you see, if I can put this side in this format, which we call it total differential, then if I have something prime equals qt, then the integral of that is, or the integral of this side will give me this left side, right? So it's good if I can put it in this format. So I ask this question, can you find a function mu t such that when I multiply mu t by this side, mu t y prime plus mu t pt y, then this becomes total differential like this. So I'm saying that this mu t is this function f, okay? So I'm saying this mu t is like this function f. So can I find the function such that this becomes mu t y prime? Okay, I say, can I find a function such that this? Question mark. Okay, let me erase this and write it here. This thing here. So I will find mu t such that mu t y prime plus mu t pt y is mu t y prime. But that is mu t y prime plus the derivative of this one times this one. Right? Okay, compare these two. What do you see? Mu t y prime, the same. This is the same as this. This y and this y, the same. It just remains this and this. They should be the same, okay? So the answer is, if I can find a function mu t such that mu prime t equals mu t pt. Okay? The answer is yes. Yes. If I can find a function mu t such that mu prime t equals mu t pt. Okay, so let's look at this. This looks like a differential equation, right? What is it? It's like mu t or mu prime, and on this side I have mu t and pt. So maybe I can, well, let me erase these things and look at that. So I have to find that mu t. And what's the equation? Let me write it here. The equation is mu prime. Let's just ignore the t. We know it's a function of time. Is mu pt. Okay, so this side I have d mu dt. On this side I have mu pt. What is this? This looks like a separable equation, right? This is a separable equation. So I can bring this here and dt here. So I have d mu by mu is pt dt. Fantastic. So if I integrate this side, I have 1 over mu d mu. On this side, I have pt dt. Don't write a constant in this case. We don't need the constant. We just need the function. In fact, if you write the constant, you will get the same answer. So now on this side, I have integral. And again, don't write it as absolute value. There's no point in writing the other side is plus minus something. So, so this side I have ln of mu, and on this side I have integral pt dt, which I'm not sure what this is. It depends on what pt is. So this gives me mu t. Mu t, if mu t is e to power. This guy here, integral pt dt, then what I said happens. So the answer is yes, if mu t is this. Well, as I said, you can add constant here. So it is saying that mu t is not unique, right? If I add a constant, I have e to power this times e to power c, and e to power c, that's times. So that e to power c, you can write it as b, and you will see that it will cancel out at some point. So there's no reason to do that. So, okay, so let's go back to our equation and write this mu t. This mu t is called integrating factor. So mu t equals e to power integral pt dt, that's integrating factor. So this mu t multiplied by left side y prime plus pt dt, sorry, what was that, pt y prime, no, pt y, y, and this equals mu t times the right side, which is qt. So if I do this, this side is in fact mu t y prime, and on this side I have mu t qt. Integrate, if I integrate, I have mu t y equals integral mu t qt dt plus a constant. So the solution is this. So the solution to this equation is simply, if I solve for y, 1 over mu t times integral mu t qt dt plus a constant inside parentheses, inside these brackets. So that constant is inside that bracket. So with the integrating factor, this is the solution. the integrating factor. This is the solution. 1 over y of t will be 1 over mu t bracket. Don't forget the constant is inside. Mu t q t dt plus constant. Now, when you have a constant, if you are given an initial condition, then you can find the constant. So, that is a solution to this differential equation. It is a linear equation, at least for calc for students. Let me give some, for a few, like 1 minute or so. So the equation was like this. It was dy dt plus pt y equals qt. So this is like derivative. So that's this is not like this is derivative. So that's I have d of y. Remember I wrote derivative as d plus pt y equals qt. I can write this as an operator, so I can write it as d plus pt applied to y equals qt. Remember, this guy here is in fact a linear operator. So d plus pt is a linear function. Since this is a linear function, then it gives me a linear equation, linear differential equation. And remember what was a linear function? If you apply it to y1, y2, it distributes over addition. And also if you write k times y, the k comes out of the operator. So this, in fact, with what we had in systems of equations, this is like that matrix A, this is like the matrix, times some vector y equals some vector q. Just compare. Okay, so I have some operator or a matrix times a vector. Well, this is vector, right? That's the function in a function space, and that function space is a vector space. So this looks like a system of equations, except we are not dealing with something finite or a finite vector space. So, but that is in fact a non-homogeneous equation. This is a non-homogeneous equation. So equals 0 will be homogeneous equation, but we will see that in second order. So we have to solve the homogeneous first. In this case, the homogeneous and non-homogeneous, they are solved together. Okay. So, in fact, this if you separate this thing, this integral divided by this is the particular solution. Constant divided by this is that general solution. Okay. So, so that the linear comes from the fact that we are dealing with a linear function. Okay, so examples. Let me find some easy examples for this is a good one. 4 plus t squared dy dt. Example. Four plus t squared y prime plus 2ty equals, on this side I have 4t. And I can say that y at 0 is, can y be 0, can t be 0, I think so. So I can say it is like, say, 3 something. So this is an initial value problem we call, because an initial condition is given. Now this is not in standard form. You have to put it in standard form. Standard form is that this y prime should have coefficient of 1. which means if it's like this, divide by this coefficient. Now, can I divide by this? Yes. This is never 0. T squared plus 4 is never 0. The minimum it can get is 4. So it's never 0. So let's put standard form. Standard form. The first step is writing this in standard form. The standard form is y prime divided by this plus 2t over, say, 4 plus t squared y, and on this side I have 4t over 4 plus t squared. Okay, so that is standard form. In this standard form, if I go back to my equation, this is the pt, right? And this is the qt. So, the thing about this, I mean, it's a procedure. So first put it in standard form, then find mu, then that's it. You have the solution. So next step is find mu. Finding mu. So what was mu t? Mu t was e to power integral this 2t or plus 4 plus t squared dt, right? So that's the pt, right? The pt dt. So let me erase this thing. So what is this? This is very easy. In fact, 2t is the derivative of the denominator. So I have e to power ln. That's the denominator. That is f prime over f. Remember, f prime over f is ln. It's not always ln. So do I need absolute value? No, because this is always positive. So I have ln of 4 plus t squared. E to power ln, that gives me simply 4 plus t squared. Okay? So the integrating factor is in fact 4 plus t squared. So let me write down the complete equation. So the solution will be, let me keep this 4 plus t squared, that is the mu t. So solution will be 1 over 4 plus t squared times integral. Qt wasn't that. Qt was 4t over 4 plus t squared times mu t, which is 4 plus t squared dt plus a constant c. So this will give me, let's see, this is much simpler. 4 plus t squared. And here I have simply 4t dt plus a constant, and that is 1 over 4 plus t squared times this one is t squared and 2t squared plus a constant. Okay, so you can leave it like this, or you can just distribute. Well, no difference. So let's see what this gives me. Y at 0 is 3. So if I put 0 for t, 1 over 4 times 0 plus c is 3, and this gives me c is 12. Right? C becomes 12. So the solution to this is simply y. T is 1 over 4 plus t squared times 2t squared plus 12. Okay, so that is a solution to this simple single variable, what am I saying? It is a simple first order linear differential equation. Okay, so let's do another one. Let me see if I give this. Well, so let me write another example for you. And remember, you don't have to go through all that formula, I mean the procedure, because the procedure, we did it once and that's it. We found a solution, y, which has mu t in it. So no reason to do that. Let me see if I can change it. That will be minus ln, so it will be 1 over that. Yeah, that's a good one. So let's write it again. 4 plus t squared, in this case y prime, minus in fact 2ty equals 4t. And let's assume that y at 0 is again, say 3. So that's the second example. The difference is that the that the function pt is different. There's a negative here. So if I put it in standard form, let me erase this. No, it's okay. So standard form, let me start from the left so I have enough space. Standard form. First thing is standard form, that is y prime minus 2t 4 plus t squared y equals 4t 4 plus t squared. Okay, now here comes the trouble. This pt is this whole thing. It's not this. You see, I have y prime in this situation plus minus 2t over 4 plus t squared y, and on this side I have 4t 4 plus t squared. Okay? And remember, the standard form was plus pt, not minus. So when I have minus, I can write it like this. So this whole thing is the pt. Don't forget that. That whole thing is the pt. So mu t is e to power that thing minus 2t 4 plus t squared dt. And that is e to power minus ln of 4 plus t squared. And what is this? Again, here comes trouble. Some students simply write it minus. This is not minus, this is caution. If you do this, everything goes wrong. Please don't make this stupid mistake. So e to power minus ln of, say, a is not simply a. What is it? Is 1 over a. It is 1 over a. Why is it 1 over a? Because I can write this as 1 over e to power ln of 4 plus x squared, and that is 1 over 4 plus x t, sorry, t squared, and 4 plus t squared. Okay, so that is 1 over 4 plus t squared. Now, the solution, let me start here so I have enough space. Y will be 1 over 4 plus t squared times integral. The right side is 4t 4 plus t squared times 1 over 4 plus t squared dt plus a constant c. Okay? So, let me, I don't have enough space here, so let me see if I can do this. And, no, I can write here. I can write here. So, so this will be, this just flips, so I have 4 plus t squared. Here I have integral 4t over 4 plus t squared dt plus a constant. Again, I have, if this is u, I have u squared, and this is d, that's the derivative of u, right? So, what is it? So this using substitution, I have 4 plus t squared, and times this will be, I can erase these things here. Because I have done everything, so let's find this integral. So if I let u okay, so 4, so this will become 2, then 4, then 2t dt is du, and denominator is u squared. And so I have 2 integral 1 over, no, not 1, u to the power negative 2 du, and that is 2 times, what is it, minus u to the power negative 1, right? So it is 2 times minus 1 over 4 plus t squared. Okay, so the inside will be minus 2 over 4 plus t squared plus a constant. Right, so if I expand this thing and look at this, so it will be minus 2 plus c times 4 plus t squared, and y at 0 is 3, so the initial condition gives me this. So the initial condition gives me 3 equals minus 2 plus c times 4 plus 0. So this gives me 5 equals 4c. So c is 5 over 4. So the solution is y, t is minus 2 plus 5 over 4, 4 plus t squared. Okay, so that is the solution after applying the initial condition. Okay, let's see let me see if I can find another nice one here for you. Oh, yeah. When I was doing, I said that I gave you an example of a simple equation that is not separable. So let's do that. In fact, it looks so innocent, but so example is I wrote something like this: dy dt equals y plus t. So in fact, it was dy dx was x plus y, right? Remember, it was dy dx was x plus y. Since we have t as the free variable, so let's write t here. Well, standard form. What is standard form? We cannot separate that. Standard form is what? You write it dy dt minus y equals t. Okay? So everything which has y should be on one side, and everything which has just t or functions of t on the right side. So that's what I did. Then what is pt? It's negative 1, right? This is plus negative 1 y, right? That is plus negative 1 y. So the pt is negative 1. And that gives me mu t is e to power integral minus 1 dt, so that's e to power minus t. E to power minus t. So y t will be 1 over e to power minus t integral. Right hand side is t, e to power minus t dt plus a constant. This e to power minus t that can go up there. Y at t is e to power t. What is this integral? That is integration by parts, and that will be minus t e to power minus t minus e to power minus t. I'm not sure if that is plus or minus. So let's find the derivative. The derivative of this time this is minus e to power minus t plus derivative of yes. I'm just lazy. T d of minus e to power minus t. Then I have minus t e to power minus t minus integral minus e to power minus t dt. So minus minus is plus, then I think it's minus. Okay. So minus minus is plus, so I have minus t to the power minus t plus integral e to the power minus t dt, and that's minus. So yeah, that's minus. So if I multiply by e to the power t, I will get minus 1 minus t5 minus 1 plus c e to the power t. Minus t minus 1 plus c e to the power t. And now if you are given an initial condition, you can find the constant c. Okay, so that was the second linear differential equations and the solution. And also I solved some nice problems for you. And you can see with this one, which has negative 1 as the p, then you have integration, unit integration by parts inside this inside the brackets. Okay, so see you tomorrow.